The topic is force system resultants. We'll talk about moment of a force, cross product, moment of a force vector formulation, and principle of moment. Okay, the applications include, in this example, is a beam, a force is applied, and we want to find the reaction forces. Another example is this hammer, which we try to find the force F sub H. In this case, the force that you need to apply to pull the nail. Another example is the moment that you need to apply to a point at distance D about the center with the force F for rotation in this mechanism. So we can start with the calculating the force in a two-dimensional problem. In this problem, the force is applied with a distance d from the center of rotation. So the moment is calculated as moment equal to force times distance. The direction can be clockwise or counterclockwise depending on the tendency of the rotation. In this example, the force is calculated. The force is shown as shown with this arrow and with the vector force, and the distance is measured from the line of action of the force from the center O that we are calculating a moment about. So therefore, that's the distance d. In this case, we can calculate the moment as force times distance d. But we can also find this moment using the components of force F, which is the force sub X, force sub Y in the horizontal and vertical direction in Cartesian coordinate system. And for that, then we can calculate force times force X times distance B, force sub Y in Y direction times distance A. Okay, so notice that the distance is always the shortest distance from the line of action of the force to the center O that we are calculating the moment about. Okay, so this is therefore can be calculated the moment as the force times A minus force X times B. This the sign is, if you consider the clockwise and counterclockwise directions, you can find that force Fy times A creates a moment that is opposite of force X times B. Okay, and the more general approach would be using the cross product, which we'll talk about it next. So in this case, in general, we can use the cross product approach, which is if you have two vectors, as you see in the figure, vector A, vector B, and cross product of A cross product B is another vector C, which can be calculated by the multiplying the magnitude of A multiplied by the magnitude of the B vector multiplied by the sine of the angle between vector A and vector B. And the direction of the result of this cross product is in the direction that is perpendicular to the vector A and vector B, in this case shown as vector C or U sub C, because it's a unit vector in that direction we can consider. And notice that we can use the right-hand rule. In this case, the right-hand rule showing you that if you bend your fingers from vector A to B, the thumb showing the direction of the cross product. Okay, so in order for us to know the result of a cross product in using the unit vectors, for example, I unit vector cross product J, the result can be shown by using the right-hand rule, as you see here, or just showing I, J, K in this form, and considering the clockwise, the counterclockwise as the positive and clockwise as negative, So in this case, if, for example, we have I cross product J, I cross product J is positive because we are going counterclockwise K. And if we have another example, K cross product J, then because we're going clockwise, then it's going to be a negative. Okay, also note that a vector crossed into itself is 0. So I cross product I is 0. We can also use the cross product calculation using the determinant, which is determinant of the first row of this determinant is ijk unit vectors. The second row is the component of vector a sub x in x direction, in y direction, in z direction. And the last row is b sub x, sub y, and sub z, which are the components of b in x and y and z direction. And then we can use the approach for calculating the determinant to calculate each component of the cross product, as you see in the figure. Okay, so we can use cross product for any kind of force moment calculation due to a force. So in this case, if we want to calculate the moment about center O, then that would be the force vector and the cross product of the distance from the force from the point that we are calculating the moment, cross product force vector here. So moment about O is R, position vector, cross product F. In that case, similarly, as I showed in the previous slide, the cross product can be calculated using the determinant. The first row is ijk components of the unit vectors in Cartesian coordinate. And then the second row are the components of r vector in x, y, z directions. And the last row are the force vector, a component of the first vector in x, y, z direction. And similarly, the determinant can be calculated to obtain the moment about O. This is again an example. In this example, we are trying to calculate the moment of a force, and the force is shown by this vector, 100 Newton, with this specific angle shown. So first we can calculate the forces in the component of the force in y and x direction, also specifying the positive direction. In this case, if you find a component of the force in y direction, that would be negative 100, negative because it's pointing down. 3/5 is the component of the cosine of this angle you can consider, or just the component of the 100 in vertical direction. And in the x direction, also similarly, a component can be calculated. Now the force if we consider the y direction, the distance between the line of action of the force in y direction is 5. And the force in x direction, the line of action between the force in x direction, the distance to O is 2. So it's multiplied by 2 to calculate the moment. And the directions are, if we are assuming counterclockwise to be positive, in this case, both are creating negative moments. And this is because if you assume the force F in horizontal direction, then that creates a moment of clockwise, which then going to be negative because counterclockwise is positive. So if you consider the moment about point O using the force in the horizontal direction, that creates a clockwise moment. And similarly, the force in y direction pointing down, multiplied by 5, the distance, that creates also a moment, which is also creating the moment in clockwise direction, if you think about it. And that's also, therefore, is negative, both negative. And after calculation, the total force is calculated, including the direction. And again, because the result is negative, and we assume that the counterclockwise positive, so therefore the final answer will be clockwise with a magnitude of 460.